Hey guys, it's me, Miss Calvin. So I'm here to go through lesson 1.1, which is getting started with statistics. It goes through some of the common basic vocabulary we use a lot in statistics and things like that. But the first thing I wanted to show you is how to use the lesson notes and how to fill them out digitally. So if you have a printer available to you at home, you can definitely just print it and write on it. That way it feels like just in class writing on it. So if that's what you prefer and you have that availability, go for it. But I did design these so that you could type in your responses. That way you can do everything digitally. So what might be helpful is if you have the notes open on your computer and then the video playing in either a different tab or maybe even like on your phone. That way you can watch and kind of type at the same time without having to flip back and forth. So when you open up the student notes file, it is a Google slide, and that's just because there's more options available for me to design it in a Google slide. But if you want to see it a little bit better, I would first go to this little zoom icon. So it's in this bottom little row right there. I'm going to click on it. And you can go to either 100%. If that's big enough for you, then keep it there. But if you want it a little bit bigger, you can go to 200%. And it seems almost too big for the screen, but if you kind of scroll over, you should be able to see everything you need to. And then what I did is I put in text boxes everywhere there's a blank. So as I'm going through the notes, you'll be filling in words in different places just to kind of keep you on track. There'll be other places where you're just flat out answering a question, but any blank spot, you're going to click on it and there is a text box that you can type into whatever the word is that needs to go there. That's supposed to say hello. It looks like it says help. So that is how you use the notes page. And then there are also text boxes over here in the questions sidebar. So as you have questions, things that come up that you want to clarify with me later, or that just you're looking for answers as you watch the video, maybe you'll answer them as you keep watching. So that's there. And then on the second page, you do have to kind of flip with the slides to see the pages. But when you get to the second page, the bottom, there is a space for you to write a summary, just for you to jot down what are the big ideas that you learned from today's lesson, what are things that you want to focus on as you are studying. So that is how you use that notes document. Again, you do have the option, you can just print this out and write on it at home, and that might be easier for you, but you can also type in your responses. So there's that. So I'm going to go back to today's slideshow and I'm going to present it and we will get started. All right, so today's goal is we're going to talk about our objective. We're going to distinguish between sample statistics and population parameters. Don't worry, all of those words we will go over. And then you're going to be able to distinguish between categorical and quantitative or numerical variables. Quantitative is just a little bit of a fancier way of saying numerical. So we're going to start by answering the question, what is statistics? So at its most basic, statistics is the science of using data to make decisions. So again, reminder, this is where you can be filling in those words on your note sheet. So at its most basic, statistics is the science of using data to make decisions. So we use the word science in this, and that always throws people off. But statistics is really a very different kind of math. It's not just solving equations or finding out what the answer is. It's a science. There's a process to it. There's a collection of steps that we go through as statisticians to figure things out. So next sentence, statisticians decide what data they need to answer a certain question. So we start with a question, this burning question that we have. We figure out what data do we need to answer that question. They figure out how they're going to collect this data. Where will I get the people to answer this question? Who should I ask? Should I do some kind of splitting up and making sure that I get certain people in my sample, etc.? So they figure out how. Then they design experiments. Sometimes we don't just want to collect survey data. Sometimes we want to figure out through like an experiment, maybe which treatment works better. So that's something we can do. We collect data either through a survey or through an experiment. And then we interpret and analyze the data. Okay? And then we report conclusions. So as statisticians, we have that process, which is why we call it a science. Right? It's process. And unlike most professions, statistics can be applied to a vast number of fields or issues. Things like the environment, right? Public safety, healthcare, it comes up a lot in healthcare, and then sports. So, and then many, many others. There's so many places and fields, and even business has a lot of statistics in it. So there's lots of places that you could be using statistics to figure things out about your field. I'm going to leave this here. I'm not even going to play it, but this is a great video that just goes through a bunch of people talking about why statistics is important. I'm going to put the link to this in Schoology. So it's a great video to watch if you're curious about why you would need to study statistics, but I'm not going to play it in this slideshow. So a couple things to keep in mind. These are a little bit of older statistics, but they're still valid, and if anything, the numbers have probably increased. But some job prospects, there's a lot of things you can go into with a degree in statistics. So statistics is the #1 on the best jobs in business in 2016. So if you want to go into business, statistician or using statistics in some way is #1 on the best job. It's the best job for a lot of reasons. And then just overall, statistics was #4 on the best jobs overall in 2017. Again, I don't know the current numbers. I haven't looked them up yet. The Bureau of Labor Statistics projected that employment for statisticians will grow from 34% from 2014, which is a while ago, to 2024. So it's grown so much. So there's lots more jobs available in statistics compared to all jobs, right? The average job growth for all jobs is projected at only 7%. So statistician jobs are growing much faster. There's a lot more need for statistician jobs than any other job that you could think of. So there's lots of things you can do with statistics. So we're going to talk about some basic definitions. So there's two big words that we use with statistics. We have a population and we have a sample. So a population is the entire group, every individual of interest, whereas a sample only includes some of them, right? So population is every individual of interest, everybody we're interested in finding out, and then a sample would only be some of them, whoever we picked. Side note, an individual could be a person, it could be an animal, it could be a plant, it could be an object, it could be jars of olive oil, it could be cell phones. It's whatever that we're interested in finding out information about. Usually it's people. That tends to be the populations that we're working with, but it could be anything. What is the same between a population and a sample? They're both made up of individuals. Again, the population is everybody we're interested in. Sample is only some people. And then as a side note, the difference between a parameter and a statistic. So these are probably newer words to you, maybe not as familiar. A parameter and a statistic. A parameter is what's true about the entire population, and a statistic is only true for a sample. So I like to remember it as parameter and population both start with a P. So population, parameter, statistic and sample both start with an S. So sample, statistic. So population, parameter, sample, statistic. What's the same between a parameter and statistic is that both are numerical values that describe one aspect of the group. And usually it's an average or a percentage. So it could be, what is the average GPA for students, right? The parameter would be maybe what's the average GPA for all students at McNeil, whereas the statistic would be maybe the average GPA for this select group of students that I picked, right? Percentage, maybe what's the average percentage of students at McNeil who wear glasses. For all students at McNeil would be the parameter, and the statistic would be what percentage of this group of students that I picked wear glasses. So parameter and statistic is what is true about that group. Parameter is for the entire population, statistic is for the sample. So I'm going to look at an example. It says you are planning to purchase food for your club's concession stand during a football game and would like to know what type of food to buy and how much. So what is my population of interest? You might want to pause the video for a second and think about it. Who or what is my population of interest? Who am I trying to find out about in this question? Is it all high school students? Maybe. But do all high school students attend football games? Not really. And could there be people buying food that aren't high school students? Absolutely. So if I'm talking about a concession stand during a football game, my population is probably not high school students. My population would be anybody who's at the football game, people who go to football games. So that could include some high school students, but it might also include some parents or some alumni, maybe family and friends, things like that. So we have to think about who is it that we're interested in to answer this question. So moving on, if I could ask individuals in that population, spectators at the football game, to fill out a survey to make my decisions as a concession stand person easier, what kind of data might I want to collect? So I have a column on your notes for you to write what parameter or statistic you might be interested in, so what thing you want to know about your population, and then what variable or question could I ask my spectators at the football game to get that answer. Again, if you want to think of some for a second, I'll give you a minute, but then I'm going to go through some common ones or some easy ones to think about. So one parameter might be what percent of the population makes purchases. So what percent of all the spectators at a football game are actually going to purchase something at my concession stand? I might want to know that. So a question or a variable that I could ask in a survey would be, do you purchase food at football games? And that's a categorical variable. It's a yes or no question. Do you purchase food at football games? Another parameter or statistic I might want to find out is what's the most popular food? What food do people eat the most? So that may be something that I want to find out. And a variable or a question that I could ask in my survey is, what food do you normally purchase? And that would also be categorical because my answer would be a word. Hot dogs, pizza, soda. It's not a food, it's a drink, but you know, right? It's a word that I'm dealing with. It's categorical. Okay. Another thing I might want to know is, on average, how much do people buy? How much money do they spend? So the average sale per person. So the question I might ask someone in my survey is, how much do you normally spend at concessions at a football game? And that would be a quantitative or numerical variable because it's a number. The answer that person would give me would be a number. $20, $10, $5.15, right? So the average sale per person is my parameter. That's what I want to know. The question or the variable that I could deal with is, how much do you spend? Which is a quantitative variable. Another example is dealing with U.S. states. So let's say I'm contacting state governments around the U.S. to compile data to compare the different states. I just want to know information about all the states, and I want to compile that and kind of compare and contrast between states. So what are the individuals in my study? Remember, individuals are who am I interested in? Who are the individual things that I want to know information about? It could be a person, could be an object, could be a plant, could be an animal, etc. In this case, the individuals would be the states. So each state is an individual. I just want to know information about the state in general. So each state in this case would be an individual. So then my population, who is the entire group of individuals that I want to know about. The entire population would be all 50 states. That's who I want to know about. And hopefully that population is actually who I ask these survey questions that I'm going to deal with. Hopefully I'm not just doing a sample of them. Maybe 50 states is probably not that hard to get the information from. So my population of interest, who I'm trying to find out about, is all 50 states. So then we have this list of variables, and I want you to think about whether that variable is categorical, is it a word answer, or is it quantitative? Is it a number answer? And then there might be some in there that are not actually variables, and if you think it's not a variable, I want you to think about why. So again, pause the video, think through each of these, and then you can play it again and see what the answers are. So size of the state would be like square mileage. Right? The size of the state would be quantitative, or numerical. That would be a number. Population of the state, how many people live there? Again, that would be a number, so it's quantitative. What are the major industries? And major industries means like what are the most common businesses or products that that state produces. And that would probably be categorical, right? Oil, etc., corn, right? So the major industries, things that are good, that would be categorical. Okay, what's the state flower? Well, that's a categorical variable. It's a word. State bird would also be categorical. the total number of interstate miles. How much roads in that, or how many miles of roads in that state are interstates? Right, that would be a number, so that would be quantitative. Unemployment rate, that would be a percentage for each state, so it would be a number, that's quantitative. Average age of a person in the state, that would be quantitative, that's a number as well. The percent of people who are school age, that would be a number, so that is quantitative. The average household income, that would be a number, so quantitative. Average household size would be a number, so quantitative. And then the last one, number of states surveyed, that's actually our one that's not a variable. And the reason it's not a variable is because that involves more than one individual. So our variables should be something that is true about each individual. So it's about one single individual. This is just telling me what is my total sample size, or what is my total number of states that I'm going to ask this question, but that's not a variable. That's just kind of a fact, things that we need to know in our survey. A variable is something that is true about a specific individual. We're collecting all of that information for all of the individuals in our sample, and hopefully as many as possible from our population. There's a question on your notes that asks, can a statistic also be a variable? So I'm going to give you a minute to think about that, about why or why not, and then we're going to talk about it. I'm going to give you a hint. The examples on this page will kind of tell you whether it's an answer or not, and that's what I'll use to explain it in a minute. So the answer is that yes, it can. If you think about it, in this particular survey, our individuals are states. So some of our variables have to do with percentages or averages. Now usually percentages and averages are statistics. That's something that's true about a group of individuals. So for example, the average age of a person in the state is a statistic that is true about that state, or it's a parameter that's true about that state. So if we had collected all of the individuals in the all of the people in the entire state and found the average age of all of those people, then that average age of a person in the state becomes a statistic. But now when I'm looking at my states as individuals and saying that I want my individual is each state and I want to know the average age of each state, now that average becomes a variable. So it's a little weird and complicated, but yes, they can be. A statistic that's true for one population might turn out to be a variable that's true about a bigger population. So this screen just shows all of the vocabulary words that we have talked about in this lesson that are important for you to know. They will come up later. You'll see questions about them on your assignments. So if you want to take a minute, maybe screenshot this, maybe pause it and write some of these down. These are the good things that you want to know and keep in your memory for later. Thanks, guys. Bye.